Hi everyone. Today we're going to study Law of Cosines. There is what we call limitation of the law of sines. And I read, unfortunately, while the law of sines enables us to address many non-right triangle cases, it does not help us with triangles where the known angle is between two known sides, and that is side angle side triangle, or when all three sides are known but no angles are known, and that is a side 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 triangle. We will investigate another tool, and this is Law of Cosines for solving oblique triangles described by these two cases. Let's begin with a triangle given two sides and the included angle, as described by this figure. Let this angle be represented by angle A, and the adjacent sides are side B and side C. Of course, we know that the opposite side here is the side A. The law of cosines states that the square of any side of a triangle is equal to the sum of the squares of the other two sides minus twice the product of the other two sides and the cosine of the included angle. In here, we're going to find the side A, which is the opposite of the included angle. In symbol, we will write A square equals B square plus C square minus 2BC cosine of angle A. For some triangles, we may look for side B, so we will use this formula. B square equals A square plus C square minus 2AC cosine of angle B. Likewise, if we're looking for the side C, so we will use this formula. C square equals A square plus B square minus 2AB times the cosine of angle C. Take note, to solve for a missing side measurement, the corresponding opposite angle measure is needed. Now, another triangle given three sides, as described by this triangle whose sides are A, B, and C respectively. We can use another version of the law of cosines to solve for an angle. Suppose we want to get angle A here, we will use this formula. Cosine of this angle A equals B square plus C square minus A square all over 2BC. This is a manipulated formula of the law of cosines that we saw in the previous slides. In words, the cosine of an angle is equal to the sum of the squares of the two adjacent sides minus the square of its opposite side, and all divided by twice the product of the two adjacent sides. Suppose we want to get angle B, we will use this formula. Cosine B equals A square plus C square. These are now the adjacent sides. Then minus B square, the opposite side, all over 2AC. And if we want to get the angle C, the formula is cosine C equals A square plus B square minus C square all over 2AB. Let us now see example 1. Solve the triangle. Given side A equals 6.2 meters, side C equals 7.8 meters, and angle B equals 62 degrees. Let us write the given and required values. On this column are the angles, and the other column here is for the sides. Angle A is unknown, so this is blank. Angle B is given as 62 degrees. Angle C is unknown, so this is blank. Side A is given as 6.2 meters. Side B is unknown, so this is blank. Side C is 7.8 meters. Let us draw the triangle. The angle A is here and the opposite side is 6.2. The angle B is 62 degrees and the opposite side is unknown. The angle C is unknown and the opposite side is 7.8 meters. We can see here two sides are given and the included angle. So we will solve for side B using the law of cosines. The formula B square equals A square plus C square minus 2AC cosine B. Let us substitute the values. So the B square equals 6.2 square plus 7.8 square, then minus 2 times 6.2 times 7.8 and the cosine of 62 degrees. Let us simplify further. This 6.2 square is 38.44 plus 7.8 square is 60.84 minus, let us get the product of these three numbers. 2 times 6.2 times 7.8 is 96.72. The cosine of 62 degrees is 0.46947. So this is rounded in 5 decimal places. Take note, you should use calculator in degree mode. Simplifying further, we get the sum of this 38.44 and 60.84. We have this 99.28. Then minus the product of 96.72 and 0.46947 is 45.41, rounded to 2 decimal places. We will get the difference. So we have B square equals 53.87. To get the B, we will get the square root of both sides. If we do that, the power 2 on the B will be cancelled out. So we have B equals the square root of this value, 53.87. And the value is 7.3. This is our B. And we use the same unit of measurement of meters. So let us copy this value opposite the side B. Now, let us solve for A using law of cosines. We may also use law of sines at this point. However, let us show that our A here is to be solved by law of cosines. So the cosine A equals B squared plus C squared minus A squared all over 2BC. Let us now substitute the values. So the cosine A equals 7.3 squared, then plus 7.8 squared, and minus 6.2 squared. Then all over 2 times the 7.3 times the 7.8. Then simplifying further, 7.3 squared is 53.29 plus 7.8 squared is 60.84 minus 6.2 squared is 38.44. Let us get the product of 2 and 7.3 and 7.8, and the product is 113.88. Now let us simplify the numerator. So this 53.29 plus 60.84 minus 38.44, we will get 75.69 all over our denominator 113.88. Let us get the quotient. We will have 0.66465 rounded to 5 decimal places. So we will get the angle A. We will use our inverse cosine. We will use our calculator in degree mode. So the angle A equals inverse cosine of this decimal value. So the angle A is 48.3 degrees. So this value of A we will copy over here, opposite angle A. So we are now to compute for C. We can now use the formula A plus B plus C equals 180 degrees, since there are two available angles here now. Substituting the values, so we have 48.3 degrees plus the B is 62 degrees plus C equals 180 degrees. Adding these two values, we have 110.3 degrees plus C equals 180 degrees. Let us isolate C. We will transpose this value on the right side. Of course, the sign must be changed. From positive, it becomes negative. So we have 180 degrees minus 110.3 degrees. Getting the difference, the value of C equals 69.7 degrees. Let us copy this value opposite the angle C in here. We are now complete with the required values. For our quick check if the answer is correct, it says here the biggest angle is opposite the longest side. The biggest angle here is 69.7 and the longest side is side C, which is 7.8 meters. Also, the smallest angle is opposite the shortest side. The smallest angle is angle A, which is 48.3 degrees, and the shortest side is side A, which is 6.2 meters. Let us have example 2. Solve the triangle given side A equals 5 miles, side B equals 7 miles, and side C equals 10 miles. Let us write the given and required values. Since all sides are given, consequently, what we're to solve are the angles. Drawing the triangle, we have angle A here with side 5 miles. Angle B is here, the opposite side is 7 miles. And the angle C is here, and the opposite side is 10 miles. Let us solve for A using the law of cosines. The formula is cosine A equals B square plus C square minus A square all over 2BC. Substituting the values, we have 7 square plus 10 square minus 5 square all over 2 times 7 times 10. Simplifying further, the 7 square is 49, 10 square is 100, 5 square is 25. In the denominator, 2 times 7 times 10 equals 140. Let us simplify the numerator. 49 plus 100 minus 25, we will get 124 over the denominator 140. Getting the quotient here, the answer is 0.88571, rounded to 5 decimal places. So let us get the angle A. Angle A equals cosine inverse of this decimal value. So we must use calculator in degree mode, and the value of angle A is 27.7 degrees. Let us copy this value opposite angle A on this side. So let us go to solve for B, again using law of cosines. Actually, we may use the law of sines to get this angle B. But for our discussion, we will continue to use law of cosines. So the cosine of B equals A square plus C square minus B square all over 2AC. Let us substitute the values. So this is now the cosine B equals 5 square plus 10 square minus 7 square all over 2 times 5 times 10. Simplifying further, 5 square is 25 plus 10 square is 100 minus the 7 square is 49 all over the denominator, which is the product of 2 and 5 and 10, and that is 100. Simplifying the numerator, 25 plus 100 minus 49, we will get 76 over the denominator 100. And getting the quotient, we will get 0.76. And the angle B is equal to the cosine inverse of this decimal value 0.76. Again, don't forget to use calculator in degree mode. And the angle B is equal to 40.5 degrees. This value we will copy on the blank in here, so we have B equals 40.5 degrees. Let us now solve for angle C. We can now use the formula for the sum of the angles equals 180 degrees, since there are two available angles here now. We may use law of cosines, but for simple computation, it's better to use this formula. So we have A is 27.7 degrees plus B, and that is 40.5 degrees, plus C equals 180 degrees. Getting the sum of these two values, we have 68.2 degrees plus C equals 180 degrees. Let us isolate C. This 68.2 degrees we will transpose on the right side, and the sign must be changed. From positive, it becomes negative. So 180 degrees minus 68.2 degrees, we will have 111.8 degrees. And this is the angle C. We will copy this value on the blank here. So we are now complete with the required angles. Just a quick check. The biggest angle is opposite the longest side. In here, the biggest angle is angle C, which is 111.8 degrees, and the longest side is side C, and that is 10 miles. The smallest angle is opposite the shortest side. We can see here that the smallest angle is angle A, which is 27.7 degrees, and the shortest side is side A, which is 5 miles. So this is our final answer. Example 3. Suppose a boat leaves port, travels 10 miles, turns 20 degrees, and travels another 8 miles. How far from port is the boat? Let us try to illustrate the problem. This is our starting point. This is the port. From port going straight 10 miles. After 10 miles, the boat turns 20 degrees to another 8 miles. This is now the final destination. Now we want to know the distance of the boat from the port, denoted by this dashed line. Let this be x. We can see now we have a triangle here. We need to know this angle, the interior angle. Considering the 20 degrees in here, we can see that the interior angle and the 20 degrees are supplementary angles. That means this interior angle is 160 degrees. Now we use cosine law. We have this formula. Substituting the values, we have now x squared equals 8 squared plus 10 squared minus 2 times 8 times 10 times the cosine of 160 degrees. Let us now simplify. 8 squared is 64, 10 squared is 100. Then we get the product 2 times 8 times 10, that is 160. The cosine 160 degrees is negative 0.93969. Now we combine this 64 plus 100. We have 164. We multiply the negative 160 by negative decimal. We have the value positive 150.35. The sum of the right side is 314.35. We get the value of x. We take the square root of both sides. So x equals the square root of 314.35, and the value is 17.73. Now we have fixed the unit of measurement, that is miles. And this is the distance between the boat and the port.